Hello. When we want to calculate a limit of a function, we have several different ways that we could go about doing that. First of which is using a table, such as the one that I have down here. And we want to look at the overall neighborhood around whatever that value is. So here in my example, I have the limit as x is approaching 2 of x cubed. So looking at the neighborhood around that would be from the lower end here being 1.9, 1.99, 1.999. That's just to use a neighborhood that's getting very, very, very close to 2, but not quite equaling 2, just so we could see what's happening with that function. So for example, if we take 1.9 and cube it, we get a value of 6 of 6.859. 859. If we put 1.99 in, we get a value of about 7.880599. If we put 1.999 in, we get this incredibly long decimal, 7.988005999. And then likewise, again for that neighborhood around what that x value is supposed to approach being that 2, we can look at the numbers 2.001, 2.01, and 2.1. Again, to get very close to this 2 here in the table. So if we put 2.001 in, we get this decimal, 8.010060001. If we put 2.01 in, we get 8.120601. And then if we put 2.1 in, we get 9.261. Now if we approach the number 2 here from the left, getting towards this 2, we will get numbers that seem to be approaching a certain number, right? 6.859, 7.880599, 7.98800599999. This appears to be approaching 8. So this approaches 8 from the left. Likewise from the right here, again going towards that 2, we have 9.261, 8.120601, 8.012006001. Both of these also approach 8. So since we have this limit here approaching from the left and from the right, both being 8, the value of that function at that particular point has to be 8. Now the second way we can look at this is by a graph. Now I drew this graph of x cubed here on my here on the board here, and the value of 8 for this would be about here, which we could see if we approach this point going up, meaning from the left, and from the right, so going down towards this point, we could see that there's no obstacle here for us getting towards the value which is supposed to be 8 here on this graph at the point 2, 8. So since we have no obstacle of it, and we could see that going from the left approaches the 8 and from the right approaches 8, so this limit here again must be 8. And we could simply just look at from the algebraic point of view with the limit as x approaches 2 of x cubed. Again, since there are no values of x that x cubed is not defined, we could just plug the 2 in. So this is equal to 2 cubed, which again is 8. So that's 3 different ways to show that the limit as x approaches 2 of x cubed is indeed equal to 8, again by a table, a graph, and then algebraically. Thank you.